question where we're going to have a look at annihilation, which is in particle physics, and a little bit in quantum physics as well, actually. So it's asking you to find the wavelength of each photon that's produced when annihilation happens between an electron and a positron. So first of all, what is annihilation? Well, actually, even before that, an electron looks something like this, and the positron is the antiparticle for this. So it's oppositely charged, but still has the same rest mass and rest energy. Those are two bits of energy information you need to know. They have the same rest energy, but they're oppositely charged. In an exam question, it will specifically tell you the rest energy. So here it's given. It is given in mega electron volts, so we need to take into account of that, and we will. So how do you find a wavelength from energy? Well, first of all, what annihilation is an electron meets its antiparticle pair, and they convert all of their energy into two photons which move off in opposite directions. What we assume is that no energy is wasted or transferred to the surroundings, and we also assume that they move off in opposite directions. Otherwise, momentum, it can't be conserved, because there'd be too much momentum going one way and compared to the other way. So what links energy and wavelength? Well, we know E equals hf. We don't know the frequency though, but we do know another equation. Frequency is speed over wavelength. We can combine these two equations, so substitute frequency into this first equation to get E equals hc over lambda. And we can rearrange that to make wavelength the subject. Lambda equals hc over capital E. And we can use this equation because we know Planck's constant is given in an exam sheet. We know C, well, it's traveling as a photon, and photons travel at the speed of light. So that would be 3 times 10 to the power of 8, the speed of light in meters per second. Now, okay, I might as well just write out Planck's constant, which is in an equation sheet, 6.63 times 10 to the minus 34. What energy do we use? Well, this has its own rest energy of 0.511 mega electron volts, and so does this. In the question, it's asking for the wavelength of each photon. One of the photons will take up the energy of one of the particles. The other one will take up the energy of the other one. So if we're finding the wavelength of just one single photon, then we only have to use the energy from either one of these, doesn't matter which one. But another thing to mention is energy has to always be used in joules in calculation. So to go from mega electron volts to joules, first you multiply by 10 to the power of 6 to go to electron volts, and then to go from electron volts to joules, you multiply by 1.6 times 10 to the minus 19. So to go from mega electron volts to joules, you first multiply by 10 to the 6, so we take our value 0.511, multiply by 10 to the 6 to turn it into electron volts, and then from there multiply by 1.6 times 10 to the minus 19. Sorry, I made a mess of that. I'm just going to rewrite it out. To the minus 19, it's too big. Putting all of this into a calculator together will give you the wavelength that we're looking for. So I'm just going to quickly do that. Just bear with me one moment. Three times 10 to the power of 8, all divided by 0.51 times 10 to the 6. 0.6 times 10 to the minus 19, and that's equal to 2.43 times 10 to the minus 12. In an exam, if it doesn't tell you, try to always round to 3 significant figures, because wavelength is essentially a distance between two peaks or two troughs. It's measured in meters. But that's enough to get you all 4 marks on this question. Thanks for watching, and if you have any questions, please just let me know in the comments. Have a good day.